Now let's look at an example where we have three graphs and we want to find the area of the region that's enclosed by them. So in this case, we have y equals 2 over x, y equals 6x, and y equals 1/6 x. And we want the region in the first quadrant that's enclosed by these three. So what we want to do first then is to graph this region to get an idea of whether we want to integrate with respect to x or y. So let's do that. So let's put these into the calculator, and we just put these in straight as 2 over x, y2 is 6x, and y3 is 1/6 x. And then let's go ahead and graph that. And in the first quadrant, after you've adjusted your window, you should see something like this. So now we need to decide if we're going to be integrating with respect to x or with respect to y. So we want to know how many regions we'll have in each case. So let's just sketch the graph over here and look at it. So this is the 2 over x graph, and then y equals 6x will be a relatively steep straight line, and then y equals 1/6 x will be a straight line that's less steep. And what we think here is that if we do this with respect to x, when we get to this line here, the top function changes from being 6x to 2 over x. For this part of it. So in this case on the left here, this part of the region, we have the 6x as the top function and the 1/6 x as the bottom function. And then after this, in the second part, we have 2 over x as the top function and 1/6 x as the bottom function. And if we were to do this with respect to y, we would still have two separate regions that we need to integrate. So we decide to integrate with respect to x, since all of the functions are given to us with respect to x. So now to set up the integrals, we're going to need to find these intersections. We'll need to find the x-coordinate here. That's the easy one. We'll need to find the x-coordinate of this intersection here, where 2 over x intersects with 6x. And we'll need to find the x-coordinate here, where 2 over x intersects with 1/6 x. So here, the x-coordinate is 0, and that's pretty straightforward. And now we need to know where 2 over x intersects with 6x. So where 2 over x equals 6x. So if we multiply through by x, we'll have 2 equals 6x squared, and dividing by 6, we have 1/3 equals x squared. So x will equal 1 over the square root of 3. And we know that we're taking 1 over the square root of 3 and discarding minus 1 over the square root of 3 because we're in the first quadrant. So the x-coordinate here is 1 over the square root of 3. And now we need the x-coordinate for this point here. So in this case, we need to know where 2 over x equals 1/6 x. So again, multiplying through by x, we have that 2 equals 1/6 x squared. Multiplying by 6, we have 12 equals x squared, or x equals the square root of 12, which we could also write as 2 times the square root of 3. So the x-coordinate here is 2 times the square root of 3. And now we're ready to set up our two integrals. The first one will run between 0 and 1 over the square root of 3, and the second integral will run between 1 over the square root of 3 and 2 over the square root of 3. The second one will run between 1 over the square root of 3 and 2 times the square root of 3. So now for this region here, we're going to have the integral between 0 and 1 over the square root of 3, and the function that's on the top here is 6x, and we're subtracting the function that's on the bottom for that part of the region, and that would be 1/6 x. And now let's add the area of the second part of the region, and this runs between 1 over the square root of 3 and 2 times the square root of 3. And in this part, the function that's on top is 2 over x, and we're subtracting the function that's on the bottom, which is 1/6x. And now if we were to solve both of these integrals, this first integral would give us 35 over 36, and the second integral would give us 2 times the natural log of 2 times the square root of 3 minus 2 times the natural log of 1 over the square root of 3 minus 35 over 36. So when we combine these two, we'll see that the 35 over 36 cancels, and we're left with 2 times the natural log of 2 times the square root of 3 minus 2 times the natural log of 1 over the square root of 3 as the exact area.